Okay, now that we are somewhat familiar with the basic features of the graph of a hyperbola, we're going to put the equation in standard form and we're going to graph it. So looking at this first example, notice that x squared is in the first term, which means my transverse axes will be horizontal. Okay, so to put this in standard form, the only thing we have to do in this case is just make the denominators written as something squared. So I'm going to have x squared over 3 squared minus y squared over 4 squared is equal to 1. So now we can identify that a is 3, b is 4, and then if we use the equation c squared is equal to a squared plus b squared, we're going to find that c is equal to 5. If you notice, there is no shift, so the center is going to be 0, 0. So let's draw the center. Since my transverse axis is horizontal, I'm going to come out 3 in either direction from the center in order to find our vertices. So here's one vertice, and here's the other vertice. So my ordered pairs for the vertices would be negative 3, 0, and 3, 0. To find the focus points, I have to come out C in either direction along the transverse axes from the center. So I'm going to come out 5 in either direction. So I've got a focus point here at 5, 0. And then I've got another focus point here at negative 5, 0. Now, to draw the hyperbola, before we do that, we actually need our asymptotes so that we can see how wide it opens. And in order to get our asymptotes, we need to know the value of b, and we need to draw our box. So, to draw the box, I'm going to come out a along the transverse axes in either direction. We're going to come out the opposite direction of the transverse axes, a length of b, which in this case is 4. So I'm going to come out here and here from the center, and this way I can draw my box. So I always come out a distance from the center in either direction from the center along the transverse axes, and then b comes out from the center along the opposite direction of the transverse axes. And then that will give us our asymptotes. Your asymptotes are going to come through the corners of the boxes and then through the center. So these points, the corners of the boxes, should be on the asymptote, the line of the asymptote. Okay, so to find the asymptote, we're going to use point slope form. Okay, so since we know a point on the graph for sure is going to be the center because it's got to run through the center, that's going to be our point 0, 0. I'll call this asymptote 1 and asymptote 2. Asymptote 1 has a positive slope because it goes up, left to right. It passes through the center, so that's my x1 and my y1, my point on the line. And then to find the slope, I just got to find my rise over run. Well, if I start at my center and I go up 4 and over 3, that's going to give me another point on the line. So my slope is going to be 4/3, positive for A1. So I'm going to have y minus 0 is equal to positive 4/3 times x minus 0. And then if I want, I can rewrite it as y minus 0 is just nothing, is equal to 4/3 x, and then minus nothing is just 0. I don't have to write that in. And then for A2, it's the same thing. I've got to go down 4 and over 3. So my slope for that line would be negative 4/3. So my two asymptotes are going to be y equals 4/3 x and y equals negative 4/3 x. Now that I have my asymptotes, I can see how wide this opens. So from my vertice, it's going to open up like this. It's never going to touch my asymptote, but it's going to get really close. And then here's the length of my transverse axes. From the center out is a distance of 3, so the whole length of my transverse axes would be 6. For my second example, to put this in standard form, notice it's pretty close to standard form now. I just have to rewrite the denominator as something squared. So I have y plus 2 squared over 2 squared minus x minus 1 squared over 3 squared is equal to 1. Notice since my y term comes first, my transverse axis is going to run vertically. My value of a is 2. My value of b is 3. And then if I use the formula c squared is equal to a squared plus b squared, c is going to be the square root of 13, which is approximately, in decimal form, which is approximately 3.6. My center is going to be 1, negative 2. Notice, just because my y term comes first doesn't mean I put my k first in the center. My h is still associated with my x value, and that should still go first when I write that as an ordered pair. So I have x minus h is 1, y minus a negative 2, so my k is negative 2. So my center is going to be at 1, negative 2. So this has been shifted. Here's my center. My transverse axis is going to run vertically since my y term comes first. So from my center, I'm going to come out 2, which is my value of a, up and down. And those are going to be my vertices. Then I'm going to come out a distance of c from my focus points, which is about 3.5. So about right here and about right here for my focus points. Now I have to create my box so that I can draw my asymptotes and come up with the equations for my asymptotes. So since my transverse axis runs vertically, I'm going to come out horizontally from the center, my value of b in either direction, which is, in this case is 3. So 1, 2, 3, here's b, 1, 2, 3, here's my other b. So this is going to help me make my box, which is going to help me draw my asymptotes. So here's one, and there's the other. So I'll call this asymptote 1 and asymptote 2. Asymptote 1 has a positive slope. The point on the graph we can use as the center for both asymptotes because it definitely passes through the point 1, negative 2. And to go from the center up to the corner of my box, I've got to go up 2 and go to the right 3. So my slope for asymptote 1 is going to be 2/3 positive. So I have y minus a negative 2 gives me a plus 2 is equal to 2/3, which is my slope, and x minus 1. So there's my equation for my first asymptote. Now if I want to put that in y equals mx plus b form, all I would have to do is distribute the 2/3 and subtract 2 from both sides. For A2, I still go through the center, so I'm still going to use 1 and negative 2 as my x1 and my y1, but this slope for A2 is going to go down 2 and to the right 3. So this is going to have a negative slope. And then again, if I want to put that in slope-intercept form, I would have to distribute the negative 2/3 and subtract 2 from both sides. Okay, so I have my asymptotes, I have my focus point, I made my box. So now I can open this up and draw my hyperbola. This one's going to open up pretty wide. And there's my hyperbola. In example 3, we have to do a little bit more work than example 1 and example 2. The first thing we need to do is add 64 to both sides in order to put this in standard form. And in order to put this in standard form, the next step is to divide everything by 64, since we want a 1 on the right-hand side of the equal sign. So I'm going to divide everything by 64. Then I'm going to get x squared over 16 minus y squared over 4 is equal to 1. And then the last step is to write my denominators as something squared. So I'm going to have x squared over 4 squared minus y squared over 2 squared is equal to 1. So now I can identify that my A is 4, and this is going to be a transverse axis that runs horizontally since my x squared comes first. My B is 2, and my C I'm going to get from C squared is equal to A squared plus B squared, which would give me the square root of 20, which I can simplify as 2 square roots of 5, and then as a decimal, I can also write it as approximately 4.5. Okay, my center, if you notice, is 0, 0. This has not been shifted, so my center is 0, 0. Since my transverse axis runs horizontally, when I draw my vertices, I'm going to come out horizontally either side a distance of A from my center. So I'm going to come out 4 this way for one vertice and 4 this way for the other vertice. So my vertices are going to be 4, 0 and negative 4, 0. My focus point, I have to come out C in either direction. So it's going to be about right here and about right here, about 4.5. Now, if I want to write this as exact, and since I'm moving horizontally, I would write this as the square root of 20, 0, and minus the square root of 20, 0. Now, to create the box so that I can draw my asymptotes, I have to come out the opposite direction of my transverse axes, which in this case would be vertically, a distance of B from the center. So I'm going to come out 2 this way and 2 this way. And now I can draw my box so I can draw my asymptotes. My asymptotes are going to come through the center and up through the corners of the boxes. There's one asymptote, and then there's the other asymptote. So my equation, since it comes up through the origin, I call this asymptote 1 and this asymptote 2. If it comes up through the center, then my x1 and my y1 are both going to be 0, because I have the center 0, 0. And then to go from the center up to the corner of my box to create that rise over run to get my line, I got to go up 2 and over 4. So that's going to be a slope of 1/2. So for my first asymptote, 1/2 x. For A2, my second asymptote, that has a slope that's negative 1/2, because I got to go down 2 and over 4, which is negative 1/2. So my other asymptote is going to be negative a half x. And my y-intercept for both of them is 0. I can write it in there if I want to, but I don't have to. And then I'm going to draw my hyperbola, and my asymptotes show me how wide this opens. Last example for finding the standard form of the equation, and for graphing, we've got 4y squared plus 8y minus 25x squared plus 100x minus 196 is equal to 0. Now notice I have y squares and y's in here, and I have x squares and x's in here. So for this one, we're going to have to complete the square. So just like the ellipse, we have to first pull out whatever coefficients in front of the x squared and the y squared. Then we're going to complete the square. So I'm going to pull out a 4, and I'm left with y squared plus 2y. I'm going to leave a blank in there so that I can complete the square. For this one, I'm going to factor out a negative 25, and I'm left with x squared minus 4x. I'm going to put a plus blank in there, is equal to negative 196. Now to complete the square, I'm going to take half of 2 and square it. So half of 2 is 1, and 1 squared is 1, so I'm going to put a 1 in here. But because I have a 4 out here, I didn't just add in a 1 on the left-hand side of the equation. I added in a 4 times a 1. So I got to add in a 4 on the other side as well to keep the equation balanced. Now for this one here, if I take half of 4 and square it, that gives me 4 again. But I didn't just add in a 4, I added in a negative 25 times the 4, which is a negative 100. So I have to subtract 100 on the other side as well. So now, when I factor y squared plus 2y plus 1, I get y plus 1 squared. When I factor x squared minus 4x plus 4, that gives me x minus 2 squared. And then on the right-hand side, if I take 196, whoops, that should be a positive because I added 196 to both sides, my bad. If I take 196 and I add 4 and subtract 100, that's going to give me 100 on the right-hand side. So the last step is to divide everything by 100 and make the denominator something squared. So I need to divide everything by 100. So that gives me 4 over 100. If I reduce that, that's 1 over 25, and I can write 25 as 5 squared. 25 over 100 can be written as 1/4, and 4 can be written as 2 squared. And then on the right-hand side, of course, 100 divided by 100 is 1. So now I can identify that A is 5, B is 2, and C, if I take 25 plus 4, that's going to give me the square root of 29. When I use my formula, C squared is equal to A squared plus B squared. And then also, if I want to put that in decimal form, that's approximately 5.4. Now, because my y term comes first, this is going to run vertically. My center, if you notice, is going to be 2, negative 1. It's been shifted. Here's my h, x minus h, so h is 2, and this is y minus a negative 1, so my k is negative 1. So my center is 2, negative 1. Because this runs vertically, to find my vertices, I'm going to go up 5 from my center. 1, 2, 3, 4, 5. That's one vertice. 1, 2, 3, 4, 5. Here's the other vertice. My focus point is going to come out a little bit more than 5 in either direction. So here's my focus. Here's my focus. And then to draw my box, I've got to come out the opposite direction of the transverse axes, the distance of B from the center. So I'm going to come out 2 here and here. So I can use this to draw my box. So that way I can draw my asymptotes. So my asymptotes are going to come up through the corners of the box, through the center. I'm not doing a very good job drawing this, but you guys get the idea. And then to draw the hyperbola, I come up from my vertex and come close to my asymptotes this way. My focus points, if I want to write down my values or my ordered pairs, it's going to be 2 for my x, but I'm moving vertically, so I take whatever my vertical value is and I add to subtract my value of c. So it's -1 plus the square root of 29 and -1 minus the square root of 29 if I want to write it as an exact value. My vertices, it's going to be from the center out a value of a, so that's going to be 2, 4, and 2, -6. And now I have to find my equations for my asymptotes. Now it passes through the point 2, -1 from my center, so that's what I'm going to use for my x1 and my y1. So I'll call this my asymptote 1 and this my asymptote 2. Asymptote 1 has a positive slope. From the center up to the corner of my box to get my rise over run, I've got to go up 5 and over 2. So I have a slope of 5/2. So I have y minus a -1, which is +1, is equal to positive 5/2, and then x minus 2. So there's my equation for A1. My equation for A2 is going to be y plus 1 is equal to -5/2 x minus 2. Because in order to go from the center down to the corner of my box, another point on the line, I've got to go down 5 and over 2. So my slope for A2 should be negative. And then, of course, if I want to put these in slope-intercept form, I would just distribute the 5/2 or the -5/2 and then subtract 1 from both sides.